So we want to graph f of x equals 3x minus 3 over x minus 2. Now, you could do this by brute force. And what I mean by brute force, you could set up a t-table, you could get your values, but, why did we learn everything that we learned how to do? So what we want to do is we want to use the tools and the techniques that we've already encountered. So the first thing that we want to do, that for me is the easiest, is to find out if there is symmetry with this function. So how do I do that? Well, remember, to find symmetry, I'm going to put in negative x everywhere there's an x. So this would give me 3 times negative x minus 3 over negative x minus 2. So that would give me minus 3x minus 3 over minus x minus 2. Now, what happens if I factor out a negative? Well, everything has out a negative, so I'm going to get 3x plus 3 over x plus 2. Oh, well, that doesn't look anything like the f of x, correct? So since it's not the same, there's going to be no symmetry. And that's really important, because that's really going to help you when we start graphing. Now, the other thing is we should find our y-intercepts. So to find our y-intercepts, remember, we're going to set x equal to 0. So I'm going to do f of 0 equals 3 times 0 is 0 minus 3 over 0 minus 2. So that's going to give me 3 halves. So that's going to be my y-intercept. Okay, so I've done that. Now what about an x-intercept? Maybe that's something we could do. So I'm going to come back in here, and now to find an x-intercept, you want to set y equal to 0. So I'm going to do 0 equals 3x minus 3 over x minus 2. Well, the bottom disappears, right? Because when I multiply everything through by x minus 2, I'm just left with the numerator. And so when I do that, I'm going to get 1 equals x. And this is going to be my x-intercept. Okay, so I've already got a few things. I'm going to go ahead and graph those. I've got an x-intercept, it says, of 1. So that's right here. So that's what I found in green. And then in blue, I found the y-intercept, which was 3 halves. So that's 1 1/2. So it's about right there. And did I find out anything else? No, I know there's no symmetry. So the next thing I should do is my asymptotes, right? And if I want to find a, let's do the vertical one first. So if I want to do the vertical, and I'm going to remember to put the P, unlike I did in one of my other videos. I'm very sorry about that. So I'm going to do the vertical asymptote. And that's going to take the denominator, and I'm going to set that equal to 0. So x is going to equal to 2. So that means at 2, I have a vertical asymptote. So I'm going to go ahead and get that and kind of put that in. So here's my vertical. That's going to come right on down here. Okay, so that is part of my battle. Now, the other thing that I can find is I can find a horizontal. Remember, we talked about that as well. So if I want to do a horizontal, then let me write that down so we make sure we're on the same page. We said that y equals, now we do the x's. Well, I've got x, the higher power. Well, I've got x to the first and x to the first. So when they're the same, remember we look at the leading coefficient. So that's going to be 3 divided by 1, which is just 3. So my horizontal asymptote is going to be at 3, so I can go find that, 1, 2, 3. Since I used black, I'll go ahead and use it so we can be consistent as we're making this thing look all clown-like. Okay, so I've got those. Now, there is no symmetry, right? So I know that I have the 2 points down here at the bottom. So most likely it's going to approach, remember, those vertical and horizontal asymptotes. So this is going to come down like this and get really close to this one, and come up here and get really close. Now, is that all we have? Well, we don't know. We need to figure out if there's something else up here in the upper right-hand corner. And really, the only way to do that is to actually enter a point. So let's say that we pick something that's up here in this top part up here, is what I'm talking about. So that would be like 3 and 4 somewhere. So what if we pick 3? So let's do f of 3. So that would equal to 3 times 3 is 9 minus 3. 3 minus 2 is 1. So this would give me 6 over 1. That's kind of cool. So there's 3, 4, 5. So there's a point right here. Now, what if I pick another point somewhere way out here? Like, I don't know. Let's do 5. Sounds good. Because that would put the point a little farther close to this asymptote. So this would be 15 minus 3, which is 12. 5 minus 2 is 3. So this would be 4. So I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4. Ooh, isn't that kind of cool? So again, I've got to connect these. They're going to get really, really close to those asymptotes, and that's what the graph is going to look like.